So let's look at a couple more problems where we're going to divide a quadratic expression by a linear factor, and we're going to end up with some remainder here. So our answer should be some polynomial, p of x, plus some remainder term where we have an integer k divided by whatever that linear expression is that we're originally dividing by. So we're going to use polynomial long division to approach these problems. And let's rewrite our expression using our division box. So we'll have x plus 2, our divisor, the number we're dividing by that goes on the outside. And on the inside, we'll put our quadratic, this x squared plus 7x plus 12. And since we have the quadratic, linear, and constant term, we're not missing anything, so we don't have to put 0 of anything. We don't need a placeholder in this case. Now, to carry out this long division, remember we're going to start by asking what would we multiply this linear factor by to get x squared? Or what would we multiply, specifically the linear term here, to get x squared? So we can multiply x by x to get x squared. So we'll put an x above the x squared. And now we just want to find the remainder for if we did multiply this, what would we be left with? So now we just need to find the remainder. So we can multiply to do that. We can take x times x, that's x squared, and x times 2, that's plus 2x. And to find that remainder, we just subtract. And remember, it's a good idea to put parentheses around the expression that you're subtracting so that you can remind yourself that you need to distribute this negative. So it sometimes becomes a little bit confusing when one or both of these terms here are negative numbers. So we take x squared and subtract x squared, that is 0x squared, which we're not even going to write. And that's what you should expect. If you're doing this correctly, you should get 0 when you subtract the first terms in each of these. Then we do 7x minus 2x, which is 5x. And to complete the process, we bring down the next number. So that's positive 12. And now we just restart. So we take our new expression here and we ask, what would we multiply x by to get 5x? And we'd multiply by positive 5. So we now multiply to find that remainder. So 5 times x plus 2 would be 5x plus 10 if we distribute. And we subtract to find that remainder. 5x minus 5x is 0x, which is what we'd expect. And 12 minus 10 is 2. So this here, this is our remainder. And from the original problem, this is what we call k. So it's that integer that we're going to divide by our linear expression. So our final answer then, using this remainder, we're going to have plus 2 over x plus 2. So when we divide this expression here, this quadratic by this linear factor, we get back x plus 5 plus 2 divided by x plus 2. And remember, there are ways to check these. So we can just remultiply to actually check this. So let me write this out again. And we just found that this is equal to x plus 5 plus 2 divided by x plus 2. Or at least this is what we think is the answer. And to check this, we're just going to multiply each side of this equation by x plus 2. Since on the left, they'll be able to cancel out, and we can see if we get back our quadratic on the right side. So let's multiply everything by that x plus 2. So basically, we're trying to see if this quadratic, since the x plus 2's cancel here, is equal to x plus 2 multiplied by what we think is the answer. Let me just make a little bit more room here. So we have x plus 2 multiplied by x plus 5 plus 2 over x plus 2. And we just need to distribute this binomial here to each of these three terms. So we get x plus 2 times x, and then we get x plus 2 multiplied by 5. Excuse me, that's an x plus 2 multiplied by 5. And when we multiply it by our last term here, the x plus 2's will cancel out, and we just get back 2. And now we just need to simplify everything. So this is equal to the x distributed to both, the 5 distributed to both, and then we'll have plus 2. So x times x, that's x squared. We get a plus 2x. We get 5x here, and plus 10 there, and plus 2. So combining like terms, we get x squared plus 7x plus 12, which is exactly what we were hoping to get, since notice we were basically trying to see if these were equal, and since we got back the same quadratic on the left and the right, we now know for sure that this is the correct answer. So we can put this into our box up top. So our final answer is x plus 5 plus 2 divided by x plus 2.